Hello, this is Phillip Pearson, and I'm here presenting with my other group members Nathan Morrow and Evan Peters. Today we are talking about sediment size as a function of Alpine glacier retreat. Specifically, we're taking a look at Highlight Canyon, Montana as our study area to use as an analog for other post-glaciated landscapes. We are taking a look at Highlight Canyon specifically because of the prominence of both the Pinedale glaciation and the Bull Lake glaciation events. The Pinedale glaciation event happened more recently and ended about 14,000 years ago, and the Bull Lake glaciation is a bit older, between 130 and 200,000 years ago. It was a bit larger, the ice made it further down the canyon, and this happened during the Quaternary Ice Age. We began our project by taking a look at Mark Webber's map he published in the Professional 1965 paper, The General Geology and Geomorphology of the Middle Creek Area in Gallatin County, Montana. In his map, he notates the different glacial deposits. Most specifically, we're interested in the Pinedale and Bull Lake moraines. He has them notated here. The Pinedale comes in 3 sets of hatches just north of the reservoir, and further down you have the Bull Lake deposits. Mark Webber does not distinguish in his map whether these deposits are recessional, lateral, or terminal moraines, but we can make assumptions based on our lab and a spatial relationship between these that the last moraine is going to be terminal with flanks that are lateral, and the 3 sets of moraines are recessional, with the last one being a terminal for the Pinedale glaciation. So with his map, we were able to determine areas that we wanted to take measurements from that are near these moraines. To get an idea of what we were working with, we took a look at some previous studies, specifically one called The Downstream Change in Grain Size of Riverbed Sediments and its Geomorphological Implications in the Kanto Plains, Central Japan, published by Koichiro Inui. I'm sure I botched that. But this paper basically talks about where stream loads accumulate and how the grain size reduction is explained through mechanical erosion, through abrasion, such, and how the hydrological conditions can override this. Basically, what we inferred is that sediment size will gradually decrease downstream. And I'll pass it off to Evan here.
So our problem statement for our proposal asks the question, how does sediment size in Highlight Creek change as a result of spatial proximity to a terminal moraine? So basically, as we get closer or further away from these terminal moraines, how is the sediment size changing? Our hypothesis to this question is that sediment size will gradually increase moving upstream towards the terminal moraine. So why might there be a relationship here? The first is that stream transport results in kind of sorting out these materials. Because moraines are these unconsolidated, unsorted material, larger particles are going to erode less quickly than the small stuff. So these larger particles would be closer to these moraines still. So we should see that increase as we get closer to these moraines. And then in terms of weathering, physical weathering increases with transport distances in glacial systems. So we see more physical weathering as we get closer to these moraine sites and these big masses of glacial material. So to do this, we went and collected data up in Highlight Canyon. We sampled 3 different locations. We sampled the Bull Lake moraine, the Pinedale moraine, and then practice rock as a unglaciated site just to see what's happening as we're getting closer to these moraines. To do this, we collected 20 samples at 7-foot intervals throughout the streams. We made a zigzag pattern across the stream to ensure that we were getting a representative sample from the stream. And here is a picture from our data collection.
After our field day, we compiled our results and found that the sediments near the Bull Lake moraine were the largest of the 3 areas we sampled. This was not directly in line with our hypothesis, where we thought that the sediments from moraines higher up in the canyon would be larger than sediments lower in the canyon. However, this does not disprove our hypothesis, but makes us refocus our experiment. In future data collection, we want to take individual soil samples from moraines. We want to find and categorize the size of the source of these cobbles and boulders. Similarly, we want to shrink the size of our stream reaches that we measure. We want to get a more accurate and precise value of grain size in specific areas of the stream. We also want to look at just one moraine and see how grain size is different above and below it, all to answer this question of how does the upstream or downstream proximity of a moraine affect the stream sediment size. Here we have the Langer campground and generally the Bull Lake moraine. Each of these dots represent a division of a stream reach that we want to categorize. We have 5 reaches downstream of the moraine, 2 reaches upstream, and 3 reaches within the moraine. We hypothesize that the largest sediments will be as the stream is cutting through the moraine. We think this because the sediments from the moraine and the glacial till will be very newly introduced to this erosional area. So they will be large and similar to how they would be as they were deposited. We think that upstream of the moraine will be the smallest sediments because it won't incorporate any of these large cobbles found in the Bull Lake moraine. The downstream area is what we're really interested in. We want to find out how the grain size is changing as we move closer and closer to the moraine from downstream to upstream. This concludes our presentation. What questions do you have for us?